All right, guys, we're going to 4.5b, solving quadratic equations by using square roots. And again, the mission pretty much mirrors that statement. I can solve quadratic equations by utilizing square roots. So we're going to actually start with something quite simple today before we get going, and hopefully this will make perfect sense to you. Let's go all the way back maybe to even first grade, second grade, where we had problems like this. In other words, we would have like 2 plus something inside of a little box equals 8, right? And so our teacher in first, second grade would say, okay, kids, what goes in this box? And we would think to ourselves, okay, 2 plus something equals 8. And we would say, okay, what number could I put inside the box that would make this thing equal 8? Well, obviously the answer here is 6. If I take $2 and I add $6 to it, then that equals $8. Well, then we move to 6th, 7th grade, and all of a sudden our teachers give us a problem like this: 2 plus x equals 8. And we freak out. I mean, we just think, oh my goodness, how in the world am I going to solve this? And we come up with all these crazy methods of, well, I've got to isolate this variable here, which means that I have to do inverse operations of everything that's over here with it. And we make a line and we say, okay, I need to subtract 2 from this side and subtract 2 from that side because my equations must be balanced. And so if I do that, I'm going to end up finally having x by itself over here, and 8 minus 2 equals, imagine that, 6. Comes up to the same exact answer. What I want you to understand is that the mission is always the same. When I'm dealing with variables like this, my mission is always to solve for that variable. And it just so happens that the way that we've learned how to solve for those is to figure out what number needs to go in here that would make this statement true. Okay, so it's really the same thing we've been doing since first or second grade. It's just maybe we're thinking about it more complexly than we need to think about it. So let's look at this problem number 1 over here. And you see problem number 1 has x squared equals 49. Well, the mission, again, is still the same as it was over here in this problem. I'm still trying to isolate that variable. So in order to do that, I'm going to have to get rid of this square because that square is attached to this x. So I need to get rid of that square first in order to do that. Well, I've got to think about, how do I get rid of a square? What's the inverse? Remember, over here I had to do inverse operations. So what's the inverse of squaring something? Well, again, if I take 2 squared, that gives me 4. And the square root of 4 also gives me 2. So the inverse of squaring something is to actually take the square root of it. So what I'm going to do with this problem that I've got here in front of me is I'm going to go ahead and take the square root of the left side. Okay, and when I take the square root of something that's squared, it's going to just leave me with what's inside that square root. But if the rule for equations is, if I do it to one side, I have to do it to the other, right? So I end up with the square root of 49. Now, I want to ask you, what is the square root of 49? And when I ask you that question, what I'm really saying is, what times itself will equal 49? And your initial answer is probably going to be 7. And I'm going to tell you that you're not incorrect, but you're incomplete. In other words, there are more than one number that will make 49 when multiplied times itself. Let me show you this. So if I take 7 times 7, it is in fact 49. What if I take negative 7 times negative 7? What does that equal? Those are the same numbers, right? And I'm looking for 2 of the same numbers that I can multiply together to get 49. Well, negative times a negative is positive, and 7 times 7 is in fact 49. So what I want you to understand is, although it is in fact 7, that when I'm talking about the square root of a number, there is actually 2 different solutions. It's not only 7, but it could also be negative 7, okay? Because either one of those, when I multiply them times themselves, will come up with 49. So there's actually another way that we write this most of the time. We would say x equals plus or minus 7, okay? So either one of these two are correct answers. You'll probably see this one a lot more than you will anything else. So this would be our correct answer. X could equal plus or minus 7. And again, I could substitute it in up here, and I would still get 49, which we just kind of proved out over here on this side. So let's use that same methodology to help us with a few more problems. Actually, we've got 4 different problems we're going to be working on today. So we'll look at number 2 and number 3 right now, and then we'll move on down to number 4. So with number 2, I've got the same exact scenario again in that I need to isolate this x. But I want you to notice that there is a ton of stuff that is attached to it. This 7 is attached to it. This squared is attached to it. And this 5 is attached to it. Okay, so I need to get rid of everything else in order that I could really isolate this x where it needs to be. Well, this is no different than other problems that we've worked before, in that we would go ahead and get rid of this 5 first, move the 5 to the other side first, so that we can begin to get this thing isolated, okay? So what that leaves us with is 7x squared, this is going to go away, equals 33 minus 5, which is 28. Now I still need to isolate this guy, okay? Which means that in order to do that, I've got to get rid of this 7. So right now this 7 is being multiplied times this x. So I'm going to divide by 7 on both sides. And again, what do I end up with? X squared. Pen has stopped. My screen just blacked out.